and negative and positive equals positive. All right. Hi everyone, it's your teacher here, Miss Bernard, and today we'll be looking at binomials. Right? We'll be looking at multiplying binomials. That's our topic for today. So let me just go ahead and present this slide to you guys. So I hope we do learn something at the end of this lesson. And we're gonna give thanks. Yeah. All right. So here we get. Let's get into it. As you said, welcome one and all to another video. We'll be looking at binomials, specifically multiplying binomials. All right. So as I always tell you, start off with motivating yourself, and this is a motto that I have created since I was in high school, and it says success is feasible through you. And this is basically saying success is able to be done through you. You can achieve whatever you want to achieve. But guess what? You got to put in the work. All right. So with that being said, let's look at our objectives for today's lesson. At the end of this lesson, I hope that you should be able to apply the distributive property to multiply two binomial expressions, multiply binomials with negative numbers or variables, add and subtract simple algebraic expressions. That's our objectives for today. Pretty simple. So we should be able to achieve all of them. Not true? All right. So let's get right into it. The first thing we're going to discuss is what do we remember? What do we remember? So let's go. Let's get it. Let's get it. So here we go. Our first question about what we remember is what is distribution? And based on previous lessons and based on what you should know, is distribution is what? I hope you said sharing sharing. First thing, sharing, right? When we hear distribution, we hear the term sharing. And in mathematics, to distribute is basically multiplying each term within the brackets by the factor that is on the outside. That's basically it. Each term in the brackets gets a piece of the number on the outside. Multiply it, you see? All right. Next one, it says in the number 2 to the 4th power, in the number 2 to the 4th power, which number is the exponent? I'll wait. I hope you said the 4. Yes, the 4 is the exponent while the 2 is the base. All right, so the 2 is the base, the 4 is the exponent. We also know 4 as to be power or index. Those are other words that we can call it, and it's also known as exponent. All right, another one. Can we add or multiply x squared and x squared? I'll wait. Yes, we can add them, of course. We can add x squared and x squared because they are like terms. So we can add them. Yes, so when we add them, we will get 2x squared. All right, we can also multiply them. So thumbs up for those who said yes, we can multiply. We can also multiply them because they are the same base. All right, when the bases are the same, you add the powers. Beautiful. So when we add those two powers, the powers are the exponents, as we learned from the previous question, is 2. So both of them have the exponent of 2, which is squared. So x squared times x squared give you x to the 4th power. Keep the base, add the powers. Oopsie. So here we go with another one. A negative multiplied by a negative gives a positive. Yes, it gives a positive. So when you're multiplying a negative and a negative, you get a positive. Negative and negative and positive equals a positive. All right. So when you add no, a negative plus a negative gives a negative. Yeah, because you owe and then you go ahead and owe some more. So definitely still owing the people them. Yeah. So when you multiply two negative numbers, you get a positive number. However, when you add two negative numbers, you get a negative number. All right. And last but definitely not least, negative divided by a positive gives a Of course, it gives a negative. So the negative and the positive divided gives a negative, right? And the division rule and the multiplication rule are the same. Okay? They are the same. All right, so let's jump right into the meat of the matter. When we talk about binomial, what are we really talking about? What is a binomial? Right? We don't know. We know, well, let's see if we can break down the terms. We know bi usually means two, but many of us maybe not know what nominal means, right? So bi means two, of course. So we're not going to be working with two things right now, right? Nominal means term. So if bi means two, nominal means term. What can you say is a binomial? Yes, two terms, basically. Simply put together, a binomial means two terms because bi means two, nominal means term. So two terms, yeah? All right. We know, as I said, these are objectives, so let's jump right into it. I'm not gonna watch a YouTube video. It says to watch a video, but as you can see, the link is there, so you can type in the link and watch the video, see what happens. All right. So here we have x plus 9 and multiply by x plus 2. These are two binomials, right? Why are they two binomials? Yes, because they have two terms. So each expression is separate part. X plus 9, the green team, have two terms. And x plus 7, the orange yellowish team, look here, I'm not so good with colors, but orangish yellowish team. Comment down below what color is this, what color it is. I say orangish yellowish. So we know that I'm going to call it the orange team. Right? Orangish yellowish team. So each of them have two terms. So the two terms in the green team is x plus 9. The two terms on the orangish yellowish team is x plus 7. Is x and plus 7, sorry. So when it comes down to distributing, we know that each term must be within the brackets must be multiplied by the factor. Now, when we come into binomials, now we're not working with one term anymore. We're working with two terms, right? So when it's separated by brackets, we know the operation that is happening. That operation is what? Multiplication. Yes. So the operation that happens when they're separated by brackets, as we're seeing here, is multiplication, right? So they're separated by multiplication. They're multiplying each other. So we can decide which group we want to represent the factors and which group we want to represent our terms that we're going to multiply, the brackets with the terms that we have to multiply. All right. So we're doing solving these binomials by using the distributive property, right? We know what is distribution, so we're going to apply what we know to solve something else. That's how maths work. We start simple, then we jump, jump, jump. Well, it's the same concept, but you know, get a little bigger and a little more fun, a little more. Yeah, think into it, but that's life, perseverance. All right. So let's say for sake, I'm going to use the green side to represent our factors, and I'm going to use the orangish yellowish team to represent our terms, right? Our different terms that we have to share the factors with. So we know when it comes on to distribution, we multiply each term in the brackets by the factor. So each term must be multiplied by the factor. So we're going to take one factor at a time because we have two factors in this one. So we have to take one factor at a time. So I'm going to start with x, right? X, boom, multiply by x. So we share that x with the other x on the other team, and we share that same x with the other term on the other team, which is the 7, right? So when it comes on to doing this, we know, let's think of a football match, right? When we go on a football team, the people come out and they're shaking hands before they start the game. Each player on the other team shakes the hand of each player on the other team, right? So my team A have to go out and shake hand with everybody that's on team B, right? So this hand right here is team A. This hand is team B. So him now first come shake hand with you, you, and you. And after he's finished, we know that the other player from the next team have to shake hand with you, and you, and you, you. All right. So it's the same concept. Think of it that way. Each player on one team has to shake hands with the other player on the other team. So X already went out and did his thing, right? So we know 9 now have to come and do the same thing because it's good sportsmanship, not true? All right. So 9 now come multiply, shake hands. So, okay, sorry. So X multiplied by X multiplied by 7, that's the job of the X. So that part is done. Let's take up 9 now. So 9 come big and bold. Don't go shake hand with X because he has to. That's sportsmanship, right? And then the same 9 goes to the 7. So it follows suit with the X. And now we have 9 multiplied by X and 9 multiplied by 7. Now we have 4 little brackets down here now. 4 little tiny brackets. And of course, we can simplify what is in the brackets. Because as we know, with BOMDAS, we have to solve in the brackets first. So x times x. Remember, what is x times x? X squared. Beautiful. So x times x give us x squared. 7 times x, 7x. Beautiful. 9 times x, 9x. Yes. And then 9 times 7, of course, gives us 63. All right. So this is now what we will have after simplifying everything within the brackets. And we're done this one. Finish. Of course not. Because indeed, for those who see, indeed, we have like terms working with. What are the like terms? Remember, like terms, they have the same variable that is raised to the same power, right? Or they could be constants, right? So variables raised to the same power here are 7x and 9x. Of course, not true. So 7x plus 9x is what is going to be adding together to get our 16x. So of course our final answer is going to be x squared plus 16x plus 63.